Get him!
I have to leave the class at, I think, 8 to 5.
We're going to get more points back.
Okay.
I have to go to the wrestling meet to help out with some wrestling things. And my mom's supposed to call and check me out, but she was kind of confused because she didn't understand why I had to be checked out if I was still in school. But I don't
Is it for a school thing? Or is it for a not school thing?
It's for a school.
Then you're still where you're supposed to be.
So even if she doesn't call and check me out, I can just leave.
I still put it into campus and say absent, left at 8:55 for wrestling thing. And then if it's legit, Pam fixes it and calls it no, you're present. Or they'll just mark it as present and say no, she was legit supposed to do a thing.
So, or should I leave at like a couple minutes early and go talk to her? Well, I don't know if there's anything that you're making
How about you turbo your way through this and then go talk to Pam?
right now.
Turbo through this and then go talk to Pam. Oh, that's right. I still have to put your quiz 2 in. I'm still working on quiz 5, but you have quiz 1 through 4 back in your possession. And graph doesn't have to be absolutely perfect. As long as we can tell where those features are, looks reasonable. I recommend always double checking on a screen, make sure that you're graphing it right. Maybe get some extra points so you know you're putting it in the right spot. I really misread your bag of cereal there, Andrew. I accidentally threw a random R in there. I was wondering why you had cereal called Crunchy Breast.
Gosh, yeah.
I'm kind of tired.
Only math class, baby.
Okay, looks like we're We have asymptotes, maybe have our intercepts, looking to finish up the graph part of it.
Hey, how do I change these fractions to decimals again?
Go to mode and switch your answers over to decimal instead of auto. Because since you input the function as a fraction, it's going to give you fraction answers if it can. Also, if you don't want to do that, you can just write numerator parentheses divided by denominator parentheses. And because then it's a division problem instead of a fraction, it'll write the answers as decimals. Yep. Hey, anyone still rolling?
Yes.
Oh, got a couple. This isn't mine. None of these are mine. Oh, okay. Took mine home. When you've had the same slinky since you were 12 and you can tell just by the feel, this isn't mine.
Really, that's kind of impressive.
Oh no, those literally aren't mine.
No, I feel it almost came with like a blanket. You would have like
No, just fidgets.
I know.
No. If there's going to be the one object that I have to have with me all the time, it's the fidget. That one.
Oh,
That I've had with me since I was probably 10.
that's
So,
right.
we there? Just about. Question mark. Okay. Now, the thunk, on the other hand, will get extremely annoying, so let's not do that. Okay. Whenever I see something that's factorable, I'm going to factor it. Once I factor it, now I know the different pieces of it and what they do. My zeros of the numerator create x-intercepts. So I know at 3 and at 1, I'm going to have x-intercepts. I know zeros of the denominator are going to give me asymptotes that are vertical. I know, there we go. And then from the original unfactored form, if I do the function of 0, I get my y-intercept at negative 3/4. And the degrees of the numerator and denominator are the same, so I look at the leading coefficients and say 1 over 1, I will have a horizontal asymptote at y equals 1. So I've got all the that. Now, the more you get to know just the behavior of these things, you start to learn kind of what they're doing. When I see a y-intercept here and an x-intercept here, I know that it's going to continue up. Since this isn't moved over where it can have a symmetrical u, I'm betting that this thing is going to cubic its way up through here. And the way that I can test that is to see if there's a solution in which y equals 1 actually satisfies this. Will it cross my horizontal asymptote? If I plug a 1 in for y, cross multiply, subtract x squared, subtract 3, divide, sure enough, at x is 7/4, y will equal 1. That means there's a specific location where I will actually go through that horizontal asymptote. Now you can also just find that by look at the screen. It's going to go through. Fine. But at 7/4, it will actually go through my horizontal asymptote. It's possible. T'Challa has said, let them through. Okay, I'm going to go through the little invisible force field there. We got to finish off the rest of the graph though. Seeing this x-intercept here, I know I'm going to curl along those asymptotes. And the way that these things work, they like to alternate, right? Positive and negative infinity. So if this is all the way down here, I'm betting this one comes up here, but I should probably find a point in that region so I know where. So like -3 what? 2. Okay. What, 11? Oh, okay. I was like, dang. It's not? Okay. 4/5 you said? 24/5. So almost 1, 2, 3, 4. Yeah. Okay. Well, they're not always going to be symmetric about that point because this wasn't symmetric about that point. Okay. I said they tend to have that behavior. You'll investigate that behavior more when you get into calc. Right now, as long as I can find my asymptotes, my intercepts, and a couple other points to wing it, you're good. Okay? So, suppose we should throw some points up there. I'm going to say exactly that. Correct asymptote, correct asymptote, correct asymptote, correct x-intercepts, correct y-intercept, labeled somewhere, and then one for your graph was close. No. Oh. One point then for vertical asymptotes. There we go. Because if you got one, odds are you got the other, right? So, anything? Okay. Then, womp, womp. Talk to me, gooses. Anything? Or is it all going okay? I tried to make sure that all the ones we had did not include oblique asymptotes yet. Did I succeed in that? Because I just like mental math glanced at it. No oblique asymptotes, I hope. No, that was from the first lesson. That was from before. Like this was just almost guess and check on the calculator. I'm saying the one that we did last night. Cool?
Yeah.
Okay. Then a reminder, the Holy Sheets exist. Holy Sheets are going to have everything that you need to have. They're in our shared Google Drive folder. All the stuff about Chapter 0. So here's all of our algebraic review, factoring, complete the square, systems, probability, our combinatoric stuff is written out like that. Chapter 1, all of our stuff about domain and range, restricting things, piecewise functions, continuity. It's all there, and then we hit this chapter, and we've done power and radical functions, all our stuff about polynomials, synthetic division, our polynomial root theorems that we talked about, inequalities we'll get to, I think, tomorrow, and then all of our stuff about rational functions that we're doing right now. Okay, so it's all there. I think I had these printed out the first week of school. Okay, so remember, that's fair game. Those are also really good for ACT review. I've got those for Algebra 2, Geometry, and Algebra 1. So if you're going to be doing a review, like you said you're doing your ACT this weekend, you want to go over some geometry stuff, be more than happy to do that. Okay, Ashlyn's over here like... Just want to make sure you know that's there. Then we left off somewhere around 3, but I'm not sure where with 3. Did we do both the ones at the bottom?
Yeah.
Yes.
Oh, cool. So, thing about having a fuzzy head. My head grabs sweaters. Holy crap. Like,
It's still on it. There's one right in the front. There you go.
okay. No. I've had the same haircut since I was 12. And it's not even a beard, I'm just lazy. Whatever. Stop it! Oh yeah, we were comparing that. There was a word problem in Algebra 2 where it was something about a hairdresser. And I just randomly asked, how much does it cost you to get your hair cut? Hair cut, not styled and colored and all the things.
Like 30.
Cut.
Yeah. She was.
Okay.
Mine's like 20.
Mine is $39.99. And that's how much it costs to get the new buzzers that I shared with the dogs. And that was 7 years ago. So $40 for 7 years of haircuts, and I do it every week or two.
Every week?
Yeah. If it gets to 3 weeks, it touches my ears, and then I want to rip. Yeah. No. In fact, that's why I have the same haircut since I was 12, because it touched my ears and it freaked. Like, I actually used to rip my hair out right there. Yeah. No, not mullet. It was the rat tail. We're talking about the 90s. The 90s. Okay. So anyway, math. Oblique asymptote, we've already talked about how we get it. Divide and ignore the remainder. Okay. So we've seen that part. We're just going to practice it a little bit more. Divide it, ignore the remainder. Notice right here, it does say the function for the oblique asymptote is right here. It does not include the remainder. They're specifically telling us ignore that part. Another thing that can happen, I've said, we don't want them to have factors in common because it creates a hole. Well, sometimes you get a hole. Okay? That's why we always factor things. Now, if that occurs, I'll have a hole at A, and then I'll just see this graph. Okay? This is the graph I see, but there's a hole here. All right? It's not that big of a deal. You just do what you've been doing. So, determine the asymptotes and the intercepts for this guy and graph. So, I know this is x, what, plus 4 minus 3. I know I've got a vertical asymptote at 3. I swear I can count. And at negative 4. I will label such. Zeros of my numerator will create x-intercepts. Right? If I say 2x cubed equals 0, x is just 0. What else can I do? How about y-intercept? Right? If I plug in 0, I'm just going to get 0 again. Makes sense. My y-intercept is already there because it was at the origin. The only thing that's missing right now is that horizontal asymptote. Well, then I see the degree on the numerator is greater than the degree on the denominator. So there isn't a horizontal asymptote. I instead have to divide and find the oblique one. So, what kind of division am I allowed to do? Because I'm dividing by a quadratic, I have to go to long division. Yeah?
Could you use the x plus 4 with I think there's
I knew it was coming. Paul's the guy. Okay, yes. You can synthetic division twice if you want. Sneaky, right? I can take 2x cubed plus 0x squared plus 0x plus 0 and divide by longhand. X squared plus x minus 12. Let's just see what the difference is in the time on them. 2x cubed divided by x squared is 2x. That belongs over. Take 2x times the stuff, getting 2x cubed, 2x squared, minus 24x. Change your signs. Shoop, shoop, shoop. Negative 2x squared plus 24x plus 0. Do one more time. Negative 2x squared divided by x squared is negative 2. Negative 2 times the stuff. Negative 2x squared minus 2x plus 24. Change of signs, but I'm supposed to ignore the remainder. Remember? I have to get a remainder, because if I didn't have a remainder, that means they were factors. If they were factors, they would have canceled and made a whole instead. So that's just it. Y equals 2x minus 2. Now, Paul, definitely the out-of-the-box thinker in the room, says, can I instead say 2, 0, 0, 0? And can I just synthetically divide twice? Well, yeah. Use a negative 4, 2, negative 8, negative 8, 32, 32, negative 1, 4. Ew. Ew, I don't want to. I know, but it shouldn't be that. Oh yeah, because we're gonna have a double remainder. Never mind. All right. Because 4 isn't a 0. Or sorry, negative 4 isn't a 0. Let's see if we can keep going with 3. See if it still results in the same thing. 2, 6, negative 2, negative 6, 26, and what's that, 60, 78, 56, 22, negative 178? Question mark? Okay.
Rick, I have a question.
What's up?
Wouldn't it be on the first one? I just missed it. Wouldn't it be 26x, not 22x
What?
for the remainder? So this is 24x plus 2x on the first one.
Oh! Alright. Yay. Okay. I was going to ignore it so it doesn't matter, right? But
4 times 32 is 128.
someone over here said 256. And they said it like 7 times, so I just wrote it.
Yeah, I know. I put in my
I don't even
calculator
know how I
3
did
times.
that.
I was on main.
I don't know. I took 128 times. Oh, Lindsay's got a point.
Oh,
Yeah, I don't know what it was. Lindsay's got a point.
What I want you to get out of it, I still divided twice, right? In all fairness, do you understand how your generation's names are spelled?
Yes. Yeah, try spelling my name without me.
Yeah. Okay.
Yeah, that's
Lynn's at Y. New Instagram handle, right? Okay. What I want you to get on this is look what happens here. I'm going to have a remainder. But I still ended up with 2x minus 2. So if you want to synthetically divide twice, okay. You have to understand you're going to get numbers at the end, and they might be gigantic. Like, depending on how the remainder works out. You either long divide or synthetic divide as many times as you can to get this. What you have to be careful about is what if I was dividing by 3x plus 4? The 0 is a negative 4/3. I would have to remember down here to divide this by 3 as well. And that's something not everyone remembers, and that's the catch between long division and synthetic division, is you might end up with a oblique asymptote that is like 3 times larger than it's supposed to be. Okay, so just be careful with it. Either way, 2x minus 2, there's negative 2, up 2 over 1, 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 up 2 over 1. Uh-oh. 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 I say uh-oh because I already know this isn't going to fit. Because that's going to cross through the oblique. It's supposed to be down here, here, here. Double check it on the calculator. I don't have enough room for the entire graph. You can go off-road. I don't have enough room to go off-road. Okay? But to get this and the one that's way down here in this corner, you're going to have to go to your calculator, calculate by table, and throw in a couple other points on there so you get the general shape of it. Okay, right? Because if you put it on your window, it's not big enough to show those pieces top and bottom. What was that? 2x cubed and 5. Y is clear. 2x cubed over x squared plus x minus 12. Right? There you go. Okay. So if I just normal graph, all I see is that central component. The window needs to be much larger than that to see these pieces. See, it's hiding down there. And just to prove that things are where I say they are, let's come over here and put in our oblique asymptote, 2x minus 2. Yoink. Okay, so you should have that, and 1, 2, 3, 4. 1, 2, 3. Like that. Okay. So in order to fit the rest of this graph, now, can I get these points to finish out the graph? Yeah. Go to my table. And just say, out here at about 14.4. Okay. Rudy was asking the same question earlier. Said, how do I get this to not be fractions? I can mode. Since I wrote the function as a fraction, it's giving me my answers as a fraction because right now my answers are on auto. If I write it as a fraction, it'll give me a fraction. I can switch that over to decimal. Alternatively, I could rewrite this as a division problem. Say 2x to the third divided by x squared plus x minus 12 like this. If I write it as a division problem, now look at the table, it's going to give me all the decimals. Okay? So if you type it as a fraction, it writes it as a fraction. If you type it as a division problem, it'll just do decimals. If you're in auto mode. Otherwise, change your mode. Okay? So, the division. Do you have a preference? Whether you would prefer long or multiple synthetic. Right? It's your choice. So, make that choice. Divide and ignore the remainder. I think we're going to do one at a time with these just to be safe. Let's start with this one because I have an a value of 1 on my denominator. Also, your x-intercepts, do not BS them and give me decimals. Write the actual x-intercepts, which are going to be radicals this time. Complete the square or quadratic formula.
Should I go and teach again? Yes. Yes.
Everyone, you're ready for Asymptotes. This is gonna be bad. No, it's gonna be really good.
Well, it's not going to be good because I'm really bad at this.
Well, I was trying to be fun. Wait, did you get permission?
Who's in charge?
You didn't say anyone. I give you permission. She's always in charge.
One of the seniors got it.
So you have the sole power.
Yes, God.
Yes, okay. So this can be factored. It can be factored.
No, he said it's radical.
They're completely square.
So do completely square.
You have to do the quadratic.
Yeah.
Literally
Or completely square.
What are we doing, guys?
Alright, guys.
Maybe I don't.
I feel like it's chapter 5.
No, go for it.
Okay, wait. So this,
How's it ending?
Okay, x squared plus 3x.
what should I do first?
Completely square.
First
Find the
asymptote.
Yeah.
How do I find that again?
You literally on the bottom.
Look at the first lesson.
What's
Look up.
x equal?
It's the zero of that, so.
Okay, that's all right. Okay.
Yes. Beautiful.
I'm not as good at it as him. Then we have to complete the square for this?
Yeah.
That is
Quadratic
ridiculous.
formula, whatever you want.
I have to first complete the square.
Then
X squared plus 3x
How?
plus 9.
Can you do complete the square with 3x?
Yeah, so x squared plus 3x equals squared.
Yeah, b over 2 squared.
Equals 3.
So it's 9/4.
And
And
then
what's the thing? Where you
3 divided by 2 squared is 9/4.
How do you find the oblique asymptote? You just divide the top.
So add 9/4 to each side.
And then you can use synthetic division for this one. So this would be -4.
Oh,
yeah.
X
X.
X squared plus.
No, x squared. What do you mean?
But it factors into x plus 3/2, doesn't it?
No, it's x squared plus 3x plus 9.
Yeah, but when you.
Oh, when you factor it,
Yeah, it factors into x plus 3/2.
Yes. And then
We're gonna skip that step, just right. Squared equals 3. Square root that.
Well, you gotta add.
Root that.
You have to add the 9/4 to the 3 on the other side.
Oh,
Don't forget that.
It's 21.
I gotta say, it's a lot harder doing this up here than it is on my paper.
Whoa. This is fun.
21 fourths.
21 fourths.
21 fourths?
Well, I'll
Yeah.
Because 3
Fourths is 3 times 9.
No, it's 3 times 4, so it's 12 fourths plus 9
You're
fourths.
right. It's 21.
Okay, so then
Square root of 21.
you can square root 4, but you can't square root.
It's pretty good, actually.
Don't forget plus 1.
No, square root of 21.
Plus or minus square root of 21
Oh, yeah.
over 2.
Yeah.
Oh, wait a minute, guys. It cancels out.
I got it.
I don't know.
I was about to say.
But they're even fractions.
Okay.
That's it. Well, it's a
Is this-
negative 3/2.
It's negative 3/2.
Negative 3
Negative 3/2.
Negative 3/2.
Yeah.
Because
What is
we have
subtract?
You're subtracting 3/2 from.
Okay. What's next, guys?
Okay.
Wait, what
So
is
those are your x-intercepts.
What did we just find?
Okay.
X-intercept.
Working together.
We're doing this as a class.
This is gonna be bad. Okay.
No, we're working together. We're doing good.
Okay, so it's like.
Also, that's a 3. It looks like just a mess, but it's a 3.
Okay, I don't know what
It looks like a 2.
So what was this?
Or an 8.
So now we find that was your x plus or
What's my
minus.
x-intercept?
Yeah. So
Those-
plus or minus, just hold that.
Just
We'll just hold on to that.
Yeah.
Okay.
Okay, now find your horizontal asymptote.
Horizontal asymptote. Okay, this is greater than that one, which means that it's an oblique, right? So we have to use division. Okay. 1. This I'm good at, so. X minus 1, correct?
Yes.
Okay. Our oblique equals y equals x minus 1. Plot this, and then it's just. Yes? Okay.
I didn't make it
After
that
that, we should probably put our x-intercepts on there, and then start graphing.
Well, the plus. Okay, hold on.
Somebody figure out what this is, because I don't know.
It's that. I don't know what it is.
So one of them is
You want me to just plot that? I know what that is. How
Yes.
about you plot -3 halves?
Oh, because you have to add, do negative.
You can ballpark it. Square root of 21 is about 4.5, 4.6. Cut it in half is 2.3. So you have 1.5 plus or minus 2.3.
So.
1.5. Negative 1.5 minus 2.3 is 3.8.
It's about 0.8 and negative 3.8.
Negative 3.8.
Yeah.
1, 2, 3. And then, what is it? 0.8?
Wait, what was that first?
You want to label them as actual compound numbers, but to ballpark where they go, you can get close like that.
Negative 3.8 and then 0.8. Those are very bad, but it's alright. Does it come down like this?
It's negative 1 point, or it's negative 8.
That's what I wrote. It's negative 0.8?
I got positive 0.8.
They got positive
Just
0.8.
kidding. You're right.
Okay, do we just start graphing? Okay. How does
What's going on?
How does it cross?
So we forget about y and
How did it cross the intercept? How did it intercept right there? That's on the asymptote.
Wait, what?
oh, it's not.
It's
It's
really
really
close.
close.
Telling you where you're gonna start.
Oh, thank you. That was a big brain fart moment. Does it go like this?
Hold on, let me. So it's just like I'm gonna run
Correct.
What about 3 or 4 upstairs?
How many do I need to put on? How did I get a second point?
Because the
We did that
first
after.
time you messed up, it was like missing the
First time you taught.
one.
We'll come back to that later.
You put 1 for everything you get wrong.
Okay, and then
So-
I'm assuming there's one down here.
Yeah, somewhere.
Your assumptions were
Somewhere.
Maybe. I am. Well, because it makes sense. Right?
Yeah, you're right.
Beautiful.
So it goes exactly.
We're just gonna. We never calculated the y-intercept.
That's what we tried to tell you.
That's a line.
Okay.
Are you enjoying this?
Little too much.
Negative 3/4.
No,
Don't
you
end,
wouldn't
don't
get
end.
anything.
At the
Yeah, what
bottom.
is that?
Well, that's.
We didn't.
You just did it. Actually, let me. I'm gonna be fair.
You owe us like a lot.
I'll give you guys 3.
Oh my
What?
Put a
He put him there himself, right? You all witnessed this? Congratulations, Andrew. You have hit 5. We expect food tomorrow. So, let's try that again.
We gotta do it again.
It's not as bad as he made it. Half of 3 is 3 halves. 3 halves squared is 9/4. 9/4 added on to both sides is 21/4. So x plus 3 halves plus or minus square root of 21/4. I'll have negative 3 halves plus or minus square root of 21/4. Find their ballpark in the calculator. It's going to be about 0.8 and about negative, what, 3.8, right?
Wouldn't it be 1? Oh, yeah, over.
Okay. Okay. And then simplify it down and get, what's that, 3.8, right? I couldn't remember if it was 3.8 or 3.3, like where the 5 went. If you have your x-intercepts, shove zeros in. Get your y-intercept, negative 3/4. Get your vertical asymptote, negative 4. You see how close it is to that asymptote? Like before I even find the oblique. When I have a intercept that is real close to an asymptote, that means it's going to hug real close to them on all of them. So with these being so close together, I would just about guarantee, before even finding the oblique, I'm going to have an oblique that's almost dead on right there. Because if this one's close, those ones will be close. Okay? Then I'll do synthetic because it's a linear factor. And get y is x minus 1. So see how close those are to that asymptote. So the question really is, how far down into that little wedge does it go? So I would like you to use your calculator and go find, like, at -3. What is it? -3, -3. Oh, okay. So -3, -3. Which also means, because I only have a single set of asymptotes here, right 1 up 2 from that intersection means I could use that to go left 1 down 2 for a mirrored point. In this case, because I only have 2 asymptotes, they will have that mirror feature. It's when you start having multiple vertical asymptotes that things get messed up. So I'll wing it with that point, and I'll wing it with these points. We'll call her good enough, as long as you have your asymptotes and your x-intercepts labeled. Okay. Can you do it when there's a 2 involved?
No, I can't.
Do it! Do it. Do it.
So if you synthetic, you divide, you have to divide it. But then you have to divide by half.
Squared minus 4x. I should probably just start doing math tutoring.
Yeah.
The ability to do and the ability to teach are 2 different things.
I would agree. It's hard.
I get frustrated with people.
Have my thoughts together.
Yeah, I go to tutor some kid and I give him a full percent and now I can't hear
Yep.
I'm like,
Mariah attempts to teach fractions to 4th grader.
Funny thing is, I was at work yesterday and my coworker was fighting like our entire host stand and him. And he's like a big guy.
Okay, I was being facetious. I didn't think you were actually going to be like physical with people. Stop that. All right, do some math.
This is fact.
always friggin' fractions.
Always friggin' fractions. -1/2, 2. 2 3/2. Square root of 6 over 2. Right? -1. Half that is 2. 2 squared is 4 is 3. Nope. -1. Quiet, you. You know what? We'll just do it later. All right. What?
Can you do complete the square for second time?
Yeah.
Yeah, it's just gonna be a positive in the end.
I literally hate this.
Negative.
Yeah, but when you square a number,
Like when it's
the second term would be.
It's a term squared. It'll be x minus 2, the quantity squared.
-4 over.
Oh wait, no, how do you what's
I
okay, for your functional asymptote, did you get
Oh no.
x minus 5? Just horizontal asymptote, how do you do that? Oh, that's the divide. I was like, hold on, let me do that.
It's gonna be
You guys are x-intercept.
So I got divide everything by 2.
Oh,
1.5. What did
really? That's
So 1/2. What's 1/2? X minus 1 point. No. 5 over.
See, the reason I couldn't teach fractions is because I don't even understand fractions.
This is
That's
so gross. That really sucks. So wait, how for your parents know?
because I divided my 0 by 2, I also have to divide my end result by 2. That's where the difference between doing long division versus synthetic, they each have their merits. Okay. So okay, we've been doing a lot of the synthetic division, so that's why I started with that. I want to show you the long division because some kids tend to freak out when long division, it doesn't magically go in there perfectly. You can use fractions. Fractions are okay. When I say how many times does 2x go into x squared, flip your wording on that. What is x squared divided by 2x? 1/2 x. Okay, then distribute. So half an x times 2x is x squared. Half an x times -3 is -3 halves x. Change your signs. Get -5 halves x plus 1. -5 halves x divided by 2x is a -5 fourths. And 15 fourths. Change your signs. Ignore your remainder. Yes.
How did you get y equals 1/2 x minus 5 fourths?
I just did that.
I did synthetic.
Oh, fraction.
Because if you divide your 0 by 2, you also need to divide your quotient by 2. Okay? So, we now got a bunch of stuff. Stuff says x-intercept at 2 plus or minus square root of 3. Square root of 3 is roughly 1.729, I think. So this is 3.729. 1, 2, 3 point some change. This is 0.21-ish. Meh. So if I'm going to ballpark them, they're right about there. My y-intercept at -1/3, so right about, yeah. Vertical asymptote at 3 halves. So And now we know an oblique asymptote at 1/2 x minus 5/4. So down 5/4, yeah. Up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Or down 1 back 2. Okay. So, you see how close those 2 points are? When I see that, when I have my x and y intercepts, and I see how close they are to it, I know there's not really a point in finding more points because they're going to be almost right on top of my asymptotes. So that's exactly what I'm going to do. I'm going to draw right on top of my asymptotes. Like so. Because when they're that close to it, even if I use a calculator to find more points, they're just going to be really itty-bitty nasty decimals. So, close enough. As long as I've got this and this labeled, we're okay. Yes? Yeah? 5/4. There we go. Okay. So what we get with this, as we're going to get with a lot of things here at the beginning, is technicalities. Itty-bitty little tiny errors where there's a lot of moving parts. Missing a negative here will do the thing. Accidentally forgetting to divide by 2 on this one instead of that one will do a thing. And that's also why you all got your quizzes back, right? How many of you had a problem that the answer was not even close to correct, but you have that somewhere up here you saw this? Domino effect. I see where you screwed up. Everything else after that is wrong. But I see where you did it. One off. Okay? Now, would you rather that I did that, or, well, if that's wrong, then your asymptote's wrong, then that one's wrong, then your graph's wrong? It's the Vader stamp of approval. Once I was but the learner, now I am the master. The student has become the master. Yeah, you get 100, you get the Vader stamp of approval. Okay. So, all right, common factors. Almost there, but we already talked about this. If I have a common factor, it just means it creates a what? Hole in the graph. So I'm going to graph whatever's left. There's just going to be a hole that I have to remember to put on the graph because my calculator will not show it. Remember, the calculator will not show the hole. You better know where the hole is. Life advice. Okay, so because the Vor Buffalo Jump is an amazing tourist destination, but if you go anywhere near it during the regular season, it's going to be crowded. So h of x is x plus 2, x minus 2, and x minus 4, x plus 2. Whenever I'm able to factor something, I'm going to factor it. If I can factor something and see a removable factor, Be careful, where is the hole in the graph? At the 0 of that factor, right? So I now know there's a hole at x is -2. But then I just graph what's left. It still has all those same features. I'm still going to have a vertical asymptote at x equals 4. I'm still going to have a x-intercept at x equals 2. If I plug in a 0, h of 0 gets me -2 over -4. I'm still going to have a y-intercept of 1/2. Plug in a 0 for x.
Oh, that's y-intercept.
Yeah. And then, what about my degrees? They're the same, so leading coefficients. 1 over 1, I'm going to have a horizontal asymptote of y equals 1. So all of that stuff is still true. It's just there's a hole at x is -2. So horizontal asymptote. If these two are the same degree, it's the leading coefficients. So if this was 2x minus 2, then I'd say 2 over 1. Y equals 2. Okay, whatever the leading coefficients are. No. Vertical asymptote at 4. 1, 2, 3, 4. We had a x-intercept at +2. We had a y-intercept at 1/2. Because I only have a pair of asymptotes, I know that it's going to have that, that mirrored shape. So if this went left 1 down, or left 2 down 1, words are hard, I'll go right 2 up 1. If it went left 4 down 1/2, I will go right 4 up 1/2. So I've got all these points, and what I'll see on my calculator is this. But I have to remember that there's a hole at x equals -2. So that means we come all the way back here to -2, and we put the hole there. Okay? That's it. That's the difference when you have a repeated factor, or a common factor, sorry. If I have a common factor, it just means there's a hole. Look at it on your graphing screen, and it will not show that hole. You have to know where it is. Okay? And try one, see how it goes. Yes, they are. Otherwise, that'd be a really bad example. Remember, you can talk to each other about the problem. You don't have to whisper. It ain't a library. I want you working with each other. Oh, also, I kind of let PreCalc decide how everything goes in here. Are y'all in the middle here? Okay. if I rearrange the middle into another U, like the big U, so there'd be like one table. So it'd be exactly what the outside is, just in the middle too. No? Okay. Well, it would be so kid here, 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 kid here. And then I would have just a random table up front that only gets used for freshmen.
Because there's a lot of people.
I'm so confused. Where's the front of the room?
Yes. I have 28 kids in that class. It takes every, yeah. Yeah, my freshman class is my biggest one. 28 kids. It takes every single chair in here.
I'm sorry.
I say we just go around the edge of the room and you just teach the center. Yeah, bring the.
Well, I've been kind of playing with that idea just because, again, I want to have that discussion. And if you're facing each other, then it's more likely you have discussion. Or what if I changed the room so that we had pods in areas instead? Like, yep. Like, it can be awkward for sitting in your chair trying to see board, but it engages you more with group discussion. So, oh, I've been thinking about it. And I kind of let PreCalc decide how that goes. Try it, see how it goes. Okay. But as impulsive as I am, I like to have plan. It is. That's why red and white are enemy colors in color pie theory. When we did that color pie test at the beginning of the year, I am through the roof red white, and those are enemy colors. They have conflicting ideologies. White is all about selflessness and order and doing what is right for the group. But red is all about impulse and do what I want and aggression. Gross.
Green and black.
Green and black says death happens, use it. There are
I'm sure there's another color in there somewhere.
there are bad things that exist in our world, but that's natural. So just go with the flow. Use it to your benefit, whether it's good or bad.
Wait, what about red and black?
Those are the sadists and masochists of the group.
Isn't that what Andy is?
I have white in mine. I have white, green, and black.
I've got them written. Yes, Andrew was Jund. That's red, green, black, which says, screw your feelings. Life is natural. Whatever happens, happens. I'm going to do me. But, yeah, I still got them all. So, we had an awful lot of white in here, which is good. That means you're trying to be decent people.
What's like the best one? What is like your good person? What color is
The I'm a good person, I think everything through, and I have a steady goal in mind. That is white, blue, and green, and we have Mariah and Anna and Colby.
Which Anna? What are we? What was mine? Was I figured. I think it was.
No. You are part of the Boros Legion. You are red and white with me. Do the right thing, or I'm gonna beat your face in.
Oh, that's cool.
Morality, aggressive morality. Do the right thing, and I will fight for it. All right, we're way off topic here. No. All right. I see a x plus 6, x plus 4. I see a x plus 4 and a x. Let's rewrite those and let's write those as x minus 3, then x plus 4. There we go. The reason for that is I will cancel out.
Wait. Oh.
Did you algebra wrong?
Yeah.
Okay.
Oh my god.
So
Well, I pretty good.
I graph what's left. I still have a vertical asymptote at x is 3. Because the degrees are the same, I look at the leading coefficients and I'll get a horizontal asymptote of y equals 1. Purely because it's 1 over 1. I have a x-intercept of negative 6. And a y-intercept, if I plug in, not f, g of 0, I get 6 over negative 3 is negative 2. So I get those 4 things. Technically there's 5 because there's a hole. We'll put that later. Because I only have 2 asymptotes there, I know that I can use my mirror to make more points. If this is left 3, down 3, I will go right 3, up 3. If this is left 9, down 1, I will also go 1, 2, 3, 4, 5, 6, 9, 1. Also, those are symmetrical. If I went horizontally 9 and vertically 1, then I can go horizontally 1, vertically 9. Right? L shapes, like the knight in chess. So I can go right 1, up 9. Or I can also go left 1, down 9. And I get a whole lot of points ready to make the graph. The catch is I need to remember that there's a hole at x is negative 4. So back here at 1, 2, 3, negative 4, I need to remember that there's going to be a hole along that graph that my calculator will not show. They're not stupid. They have a 1992 color display. The lowest point? Oh, because this was 9, 1, I went 1, 9. Again, because I only have the 2 asymptotes. So you're going to be symmetric about that point. All right, we're okay with those? If we can stay on topic. If you can't solve this, you probably failed Algebra 1.
That's awkward.
No, we're not going to do that one. We're okay. Subtract it to the other side. Cross multiply and solve, right? So x squared minus 8x is negative 6. And then add 6 over. Wait a second, maybe I should leave that 6 over there because last I checked, there are no factors of 6 that add up to negative 8. It is not factorable. So if it's not complete the square, I'm going to say half of negative 8 is negative 4. Negative 4 squared is 16. Write as x minus 4 the quantity squared, 10. So I'll have plus or minus square root of 10, square root this side, get x minus 4. I'll add that 4 to the other side. Do you see why I like complete the square over quadratic formula? It is faster. It really is, if you're just not afraid of fractions. Okay? So, before I move on, though, look at my original problem and think about the commandments of domain. Thou shalt not divide by 0. This is a rational equation. A rational equation means I have an x on denominator, so I have the possibility of breaking the first commandment. Will my solutions break the first commandment of domain? No. So we're okay. You have to check your work for extraneous solutions now because of that. Go ahead and cross these out. These are beyond lame. Like, this is algebra half. I'm literally doing this next week with algebra half. I don't know why this is in here. Okay? But this, that's algebra 1. This is algebra 1. Now, how do you cross multiply if you have two things over there, though? I have to put them together. How do I put them together? I have to have common denominators. Just like if I said 3/5 plus 2/4, 2/41, screw that. Okay. If I had this, I would not be able to put those together. I would need to times 41 times 41. I would need to times 5 times 5 and say the whole thing over 205. 123, 133. Okay. I would need to get common denominators in order to put together fractions. I have to do the same thing here, it's just they're entire rational expressions. So, this, okay, well, do I have to do both sides? Isn't this x minus 2, x minus 4? Okay. So, I need common denominators. Do not try to freshman this and say, I'll subtract 2, I'll subtract 2. I will, like, no, bad. This is an entire factor. All right, this is a difference of two terms. I have to treat the entire thing together as a factor, entire thing. I need to multiply by x minus 4 and x minus 4.
That's what I did.
No. Why would I multiply it by 2? Is that x minus 4?
Just change the add from multiply and it'll be the same.
Just
So
switch sides.
Okay, remember what I said about Paul thinking outside the box? We're going to put Paul back in the box. You need to multiply by the entire binomial in order to get the common denominators. So now, I have 4 over this stuff, x squared minus 6x plus 8. Over here, when I distribute, I'll have a 3x squared minus 4x. Here, I'll have a plus 2x minus 4. All over. Now that they both have x minus 2, x minus 4, then they're both over that. Okay. Now, so what I'm showing you is that this quadratic is this pair of factors. They are the same, right? So if that's true,
Wouldn't it be 12x? That's what I'm confused about. It's the 3x times.
oh,
It'd be negative 12x.
I'm going to veto that one because y'all just loud and obnoxious and I can't think right. So
Everyone that unclasses veto, say aye. Aye.
I don't.
Yeah.
as we saw for 4 years, if the executive branch has its head firmly, then they can veto everyone else. So
Yes. It's not worth it.
okay.
Oh my gosh.
Hey, make this a lot easier. If I said 3 over pi plus 16x over pi is 38x to the 9th minus 25x to the 3rd over pi. If I just had a bunch of crap over pi, what could I do to not be over pi? So what would happen if I multiplied the whole honkin' thing by that quadratic? If I took this side times x squared minus 6x plus 8, and this side times x squared minus 6x plus 8, womp, womp, right? It's just going to cancel. That's the point of what we just did. Not just to combine like terms, or not just to combine the two fractions, but now everything is over the same denominator. So I can just multiply by that denominator and make it go away. I now have 4 is 3x squared minus 10x minus 4. It's now a quadratic. Solve the quadratic. 3x squared minus 10x minus 8 is 0. Factors negative 4 plus 2. And we'd say x is negative 2/3 and 4. So I had to get common denominators so I could smash those two on that side together. Once I did, we're not done yet. Once I did, I was able to say, well, if I just multiply by that denominator, it'll go away. So I don't have to, because the alternative is right at this stage, cross multiplying. Do you want to cross multiply a quadratic with a quadratic? Yes. You're going to end up with a quartic. You're going to have to solve the quartic. The quartic will have two imaginary zeros. Or I can multiply by the quadratic and not deal with it. Okay? Now that I've gotten to my answers, I have to remember the commandments of domain. Thou shalt not divide by 0. Will either of these two solutions make me divide by 0? So I now need to start checking things again. Anytime that you have an original equation that has radical in it, has a x on denominator, has a logarithm, you need to check because you might have broken math. Okay. This problem right here, the last time you saw it was Algebra 1. That's why we're taking that out of Algebra 1.
Oh, that's the thing that you're taking out.
We're moving that to Algebra 2.
There goes the ball.
Why is it so cold in here?
Algebra 1 textbook.
See, I would be like, oh, but I don't want to.
Okay.
Algebra 1 was like 5 years ago.
All right. Today was really dumb. We should have finished and then some. I understand part of that is my fault. No homework. Okay. However, tomorrow's assignment might include both 2.5 and 2.6 and be longer than usual.
It's fine.
It would be over a 3-day weekend, so
I will not be here tomorrow.
bummer.